All right, so we are now back into the agent model. We are looking at how your algorithm was implemented in the agent model. I started looking at this a bit earlier, so the interbot communication here. Okay, so here we have the outbound and the inbound. So this is what it sends out, and this is what it receives. So the information that is being transmitted is the W vector, the initial W vector. So of course this doesn't change once it's being initialized, but we still need it. And the XY reference, or the XY star in your yeah, so this is what is being communicated to the other robots and the control center. Now here enable let's see, just want to make sure something. Okay, so in the data bus, maybe I wasn't clear about this. Maybe I'm not sure I mentioned it actually. So the agency matrix is created in the control center, but it doesn't stream out the agency matrix to every robot. It simply streams out and the vector that corresponds to the robot. So robot 1 is allowed to have the vector that corresponds to the first column, vector robot 2 the second column, etc. And so this is ones and zeros, of course. And so here we go get that, and we multiply it once this is open, and we multiply it by this to open the connection if it's allowed to communicate. So if it's not allowed, then it just simply does not open the communication. So it will stream zeros instead. This is where the zeros are. So this yeah, that's pretty much what it is. Anything else to say here? I guess no, it's the W matrix. Oh yeah, when it receives it, it always receives a vector, and then it reshapes that vector into a matrix. So that's what's going on here. So we see that it receives a vector of 16. Okay, then it gets, okay, well, we know that the first element is this, the second is this, etc. And then it creates, well, in this case, it creates a bus of 72, and then it creates the W of the agent here. And I guess this is another important part. As I said, the W matrix as a 6x6 matrix or n by n matrix doesn't really exist. It's actually a 6x6 matrix. And this 6x6 matrix is the layer that corresponds to the agent. So again, I hope that was clear. Okay, so then here we have your algorithm. So when it is activated, can go here, and this here is the code related to your algorithm. I had to rethink it a little bit because, well, not rethink the algorithm, but just rethink how it was going to be implemented because of the fact that it's a 6 by 6 by 6 matrix, and the fact that they're receiving vectors, and so yeah, so you might want to dive into this, analyze it really understand it, because it kind of gives slightly different results, but necessary for implementation. So yeah, we start off with a 6 by 6 W agent. So with sleeping is because there's the sleeping robots. But then we remove that to have, for example, the 4 by 4 or n by n matrix. So once we start going in there, we remove the ones we don't want. So here, reset weights. So if you want to reset the weights, this is where it's done. Remove the sleeping agents. Okay. Let's see if there's anything. Oh, this is just if an agent comes online spontaneously or goes offline spontaneously. This keeps track of that. It's going to fix that here, but don't do that because apparently we have to prove that, and I didn't prove it. But yeah, it works. Well, actually, yeah, it works when we remove an agent, but not when we add an agent. And this is just a bug in the code. It's not because it doesn't work. But I didn't have time for that. Okay. So yeah, I don't know if there's anything I need to say here. I think it's relatively straightforward. Yeah, when it changes the weights, here's the code where it changes the weights. Oh yeah, when we initialize, we simply give the other rows, instead of giving them random weights, we give them the agents random weights. So the weights that are given to the other weight agents that it communicates with, let's say agent 2 communicates with agent 1 and 3, and agent 3 communicates with agent 1 and 2, and there's a fourth agent, but the weights initially attributed to agent 1 by agent 2 are going to be necessarily different than the weights attributed to agent 1 by agent 3. So that's where the n by n matrix comes in. That's one of the that and the asynchronous. So yeah. I mean, there's probably ways to extract all that information, all that data, to know what the real n by n matrix is. I haven't done that. It just I haven't had time, actually. I just finished on the very last minute. So and yeah, I think that's pretty much covers that, actually. So yeah, so when it's activated now, of course, this changes the target, because the target is now not determined by predetermined position or following the joystick remote. now it's determined by the algorithm. So yeah, so this is what we see here where the target changes. So you have the algo target here when it's activated, and otherwise it just goes to the normal target. And I think that pretty much covers everything. I am sure you will have questions because I'm sure I forgot probably a bunch of stuff or that I wasn't clear. Don't hesitate to reach out anytime. If I can answer, I'm going to answer as soon as I get the message. So yeah, I hope that was clear, and talk to you soon.